Okay, let's get started. So once you've launched the GMH script, the script is pretty much broken down into two sections or two halves. The first part is the creation of the hair using physical geometry, and then the other half is the Maya hair system that has its own properties for changing the curl, changing the amount of hairs, the density, the thickness, all those basic Maya hair functions. So, and then on top of that, we can also choose, do we want to use the Maya hair approach, or do we want to have polygon planes with transparency maps, almost like a gaming type of workflow. So there's two ways of essentially working. The first method I'm going to show you guys is going to be just the basic Maya hair method. And essentially how this works is you create your GMH style, and just by clicking the green button, this is the first step that you have to do every time. You click on that, it's going to pop up with a create new hairstyle window, and you can call this whatever hairstyle you want to go for. Let's like in my case, I'm just going to write down demo, and there's a little checkbox there which you can then switch from regular like Maya hair to actual Polygon style hair, which uses the transparencies. So for now, we're not going to use that button. We're just going to hit OK, and that should then essentially prepare the whole node system for us that will automatically generate the hairs from the polygon planes that we will be producing. So you'll always have to do this. You can also go and rename it if you want to, just by clicking the rename button. You can delete the hairstyle. You can save out presets, and then next time you want to use the same kind of preset with the same style hair curls and all those kind of things, you can open that up and have access to it. I'll talk about these, the edit style and Maya hair and paint effects a little bit later. But to get into the actual thing, we need to first create some basic geometry that we can associate into that particular hair system to use that surface and then generate the Maya hairs from. So I'm going to start off with a very basic kind of polyplane. I'm going to create a polyplane, move that out a bit, and I'm going to extrude a few segments out of this, maybe 2 or 3, and I'm going to widen the actual loop as well, something like that. So I'm going to create another object, and this time it's going to be a Polygon Cube. So the Polygon Cube is going to be this guy. Pretty much running through the same process of extruding that with a few divisions. And I'm going to use offset to kind of taper that. I'm going to use a cylinder. So you can pretty much use any surface if you like to kind of generate the volume for the hair. Okay, I'm going to reduce this down to about 8. I'm going to add about 2 or 3 caps. Stretch out the height. And just change some of the properties on the cylinder to kind of show you guys that the width of the actual geometry will matter for the sake of the hairstyle as well. So let's do something like that. Should be good enough. Okay, so at this point I've got a plane, flat plane, no thickness. Then I've got a cube. It has thickness and it has volume. The one side is tapered, the other side is just the default size. And then finally the actual cylinder that I've essentially manipulated into a more custom kind of volume or shape. So you can pretty much use any of these parameters for the generating of the actual hair. So this is quite simple. It's just a matter of selecting the geometry that you want to associate to the hair system, and then on this side we just say apply GMH style. As soon as you click on the button, it will essentially add or pen that piece of geometry into the menu, and then you can see the hair is being generated from that. Now, to take it one step further, you can currently see that the direction of the hairs are flowing from base to tip on this side, and we want it to go the opposite direction, from base over here to tip over there. So all you have to do is just change the rotations, and it's essentially just choosing different sides to the face to kind of guide it to grow from different directions. So just by clicking that, we can get it where the base is over here and the tip is over there. Now it's a live connection, so you can essentially just keep going and keep modeling the actual polygon plane, and that will automatically adjust the positions of this piece of geometry and then generate the hairs accordingly. So if I select this and I do an extrusion, how's it, guys? And you can see how that kind of changes the dynamic of the hair. From there, you could then also start widening out the actual hairs, and it will try to compensate the width of the hairs and interpolate the path for me accordingly. So usually you would then start creating these kind of widened shapes. Now if you want to add more hairs, we need to divide the plane into more segments. Now, not segments along the length, but rather segments going through the width of this polyplane. So I'm going to select that edge and I'm going to divide that through the center. Typical polygon modeling workflow. I'm going to use a multi-cut, split that up, and the only thing that you'll notice now, the hairs are not interpolating properly like they're supposed to. So what you'll have to do is just update that by clicking this button again, and it's going to refresh and change accordingly. So now we can see there's a lot more density. So with that additional loop, we can then go and change the flatness of the plane, being, you can see that the hairs are all in the exact same plane. We can start grabbing some of these edges, like this one and this one, and then pull them out so that they're spreading over a wider area, and that's giving you a lot more volume for the same plane. We can then just keep adding additional loops. Select the polygon surface, click on the rotate button until it spins around the right direction again, and then we have new interpolation according to those edges. So that's essentially the basic workflow for it. And since these are actual Maya hairs, you can then associate a dynamic simulation to it so that they actually blow in the wind and do all the typical dynamic properties. So what I want you guys to do for me is pretty much repeat the same thing. I'm going to keep it basic and run through each section of the plugin, and then address any technical issues that you guys might have. Okay. Continuing, if we have a look at this little cube, we're essentially going to have the same result as what we have on the left hand side. The only difference is that this is a bounding box, so it essentially associates the geometry as a volume. So from each side it's producing, think of the cube now, or the extrusion that we have, as the volume primitive, and then from that it generates a full thickened area of where the hair is coming from. The plane itself is only as a thin plane, so it's localizing the details on a flat area. Whereas with the cube or the cylinder, you're essentially, just rotate this around. One more. One more. Right, so now you can see it's essentially generating that hair coming from this area and going all the way there. So the only thing is the cube should technically not have the outer faces. So if we select those, it's going to propagate to a flat point, and then also the same thing on that side. And then when we spin this around, 1, 2, 3, there we go. So now it's coming from all points around that area going towards the tip. So you typically use the same kind of extrusion techniques. You just select the edges and you kind of keep extending them and moving them around, shaping the loops to your liking. So if you want to generate a lot of volume very quickly, this is a nice way, because it's not just a flat plane as this one is. So this one is quite nice for long hairs and hairs that you want to specifically place in an area of choice, where this is to generate very large volumes very quickly. So the same technique applies to this as well. I'm going to select apply. So I'm going to generate those hair fibers. Come on. Come on. There we go. Get rid of these points as well. Those just kind of mess up the whole style. Go back to object mode, rotate once, rotate again. There we go. So this is just a little bit smoother result than the actual box. But at the end of the day, you can pretty much squash and stretch these guys as much as you like. If you do that, it kind of looks very similar to the actual flat plane as we have here. So you can start off flat and then eventually start widening these out using your object scale, and that's going to start spreading out the hairs like that. So you can do that as well. There's so many ways of approaching it. Okay, that's the most basic kind of approach for how the script works. I'm going to quickly give you guys some time to do that as well. So the next part involves essentially tweaking the actual hairs, and the thing is, how the script is designed, it essentially locks certain things that you're not going to manually control it, as you would do with a regular Maya hair system. So once we actually get into Maya hair, I will show you guys exactly what I mean by that. But essentially, the geometry is the only thing that's selectable or editable, if I can call it that, in terms of selecting it in the viewport and manipulating it. Other than that, if you wanted to essentially tweak the physical hairs, if you're trying to select things, you can't. You're just unselectable. So what we need to do is, in the GMH hair scripts, there is a button called Edit GMH Style. So as soon as you click on that, it's going to launch the actual hair system properties, and this is like a short list of attributes that you would typically get in the regular Maya hair properties in the attribute editor. So it just kind of localizes the most oftenly and commonly used attributes specifically for the scripts and for the user, to make it easier for them to style the hair and do all the crazy fancy stuff. So over here, if we have a look, let's start at the top of the actual hair system. So once we click this button, you'll see that in the outliner there is a demo GMH hair system. That's the actual node that kind of clusters all the attributes relative to the hair that we're generating. The demo hair system is essentially the actual Maya hair set of properties. If you have that selected, you can actually control it like the regular Maya hair attributes. And then it's got the PFX, which is the paint effects attributes, and then the demo stroke is also related to the actual paint effects. So we don't have to manually select them unless we want to access more advanced properties to control it that way. So what I want to do is I'm just going to click on the Edit GMH Style, and that's going to give us the short list of that same set of attributes that you would typically get in the Maya hair system over here. So from here you can change the attributes like the clump width to kind of spread out the hairs over a wider area, and you see the scale value goes up to a maximum of 1. For most of the attributes in Maya, you could typically override this just by typing a higher number, and that's going to give you more spread over that particular attributes. So if you type in 5, for instance, you can really try to fill this in with a wide clump width for the actual hairs. Now think of it this way: the actual geometry that we created from this set of primitives, whether it's the plane, the cube, or the cylinder, this is considered the main clump. In a typical Maya workflow, you would actually generate a single Maya curve, and that curve would essentially generate the clump of hairs going around it. So the workflow for this would then be to have multiples of these planes that essentially represents each their own set of clumps. Okay, so by changing these attributes, we're essentially controlling each one independently for whichever primitive we have selected. So if I have to tweak, let's say, that one over there or this one over there, you would select it and then you change these options. So looking at the overall clump or the hair width, this is an attribute that you would not typically see changing in the attributes. You might think it's broken or not working. You essentially have to render it out to be able to see the thickness of the hairs. That's how it's going to render out, the thickness of the hair. If you want it really thick, and let's quickly do Maya IPR, bring this into view, and just draw out a section. And as I reduce this to a lower value, I'll probably have to re-render that. You can see it's much thinner. So these are the individual hair strand thickness and not the clump thickness. Okay. So another way to actually preview this in the viewport is to change the default way that the Maya hairs are previewing. Instead of hairs, you would preview them as physical geometry, and this applies to regular Maya hair as well. So to do that, you need to turn on the paint effects to preview as polygons. So I'm not sure if they have a shortlist attribute specifically for that. Let's quickly have a look. There is a demo PFX brush. Stiffness. Yeah, I'm not going to spend too much time trying to find it. I'll just manually select the PFX hair on this side in the outliner and then click on draw as mesh, and I don't know if this is going to override it or not. Let's see if we go back to edit and then increase or decrease. Yeah, you see some of these attributes are non-accessible if you manually go and tweak them on or off, so that kind of sucks. I was really hoping that we can just go to the shortlist and find an attribute for that. Maybe it's just hidden under one of these other options. Draw overrides. Brush width. Nope. I'll look into it and see if I can find a particular attribute for that. Maybe if we click Edit PFX over here. No. Okay, doesn't matter. But essentially, if you want to see it, you can just render it out, and that's going to give you exactly what you're looking for. Right. So going from there, if we have a look at the rest of the shortlist, there's an options for changing the way that the simulation is going to work. If you say to all follicles, each follicle, meaning every clump, will act as a dynamic simulation. So in certain situations, you might require a setup where certain hairs will be dynamic and other hairs should be more static. You don't want all the hairs to kind of just blow all over the place. You might want to have only single strands, like let's say you have bangs that should blow through the wind, or a ponytail or something like that, and only those hairs should be dynamic, nothing else. Then you can actually set the follicles to be more specific by changing it to dynamic follicles or static follicles and so on. Right, so the display quality is an overall slider that trims down how it's being previewed in the viewport. It's nothing of the quality at the render time. This is literally to reduce the amount of overhead in the viewport, so that if you have 100,000 hairs or 10 million hairs, that it doesn't go and actually kill Maya. Okay, so you can actually drop this previewer down, and all it does, it's propagating the percentage of hairs being previewed in the viewport, but as if I were to render it out, it will still render out with a thick same value as we initially had. Okay, so just changing that in the viewport will help you to not have too much hairs being simulated or shown up in the viewport. Right. The option for hairs per clump, that's the amount of hairs that will be generated per clump based over the width of the clump. So if we increase that to something like 50 hairs, we're going to have a pretty good density of hairs. Again, that display property will preview either the 50 hairs per clump or 4% of 50 hairs per clump. So that's essentially how those two kind of work hand in hand. The next attribute is more related to the actual let's call it segments of each hair. And if we look at the base of our initial polygon surface, we have very few subdivisions that's essentially representing the bending or the curl of our subdivision or our mesh. And technically, when you're generating the hairs, it's going to use the edges to create a single point or placement point for the division of the hair. And usually that's not enough to capture a lot of the details, especially when there's a lot of curl or noise or turbulence, all those kind of modifiers in it. So what you would typically do then is you would increase the subsegments, and I'm going to just preview this to be a more visible kind of thing. You can see that there's an obvious division right there, there's another one, and so on and so forth. As soon as I increase the subsegments, that's going to start adding additional subsegments within or between those primary ones. So now if we increase this quite high, something like 10, we're going to have 10 per subdivision or per section. And that really helps to kind of smooth out the hairs and the curls for when we start adding more displacement details down here at the bottom. Right. So that's the main hair system properties that you would always want to be playing with. Additionally, you can change thinning, especially if you don't want all these hairs to kind of be perfectly trimmed off at the tip. You want to have some of them kind of splayed out as if they're broken off, or just they either grew shorter or they just fell out, and some of the hairs are longer and some of them are shorter. That's a nice attribute to give some additional breakups. The hairs width scale. This width scale is essentially combined directly to the hair width property over here. So think of this as the root on the left hand side of the graph, and think of that side as the tip, right? So if I change the width of the hair, it will show up thicker in the middle than it does at the tips and at the base. So if I flatten out this all the way to 0, then it's going to be super thin, like 0 pixels width, if I can call it that. And typically that ends up rendering longer because you have to add additional anti-aliasing samples to make it look good. So you don't want to make it too thin, nor do you want to make it so thick that it looks like straw. So you have to find a balance between what looks good and what renders quick. Right, so clump width scale, this is just the overall profile of how this kind of goes from base to tip. And if I increase the base, you can see how that kind of fills in the base area. And then at the tip, you can also splay them out. If you want to all of them point to a single tip, you can do that. And you can change with this property as much as you like until you find a nice balance to the look and feel that you want to go for. Going from there, we have clump twist. This is each clump is twisting around their own follicle points. So if I click and drag this, you can actually see they're just spinning around their own local axes. Now, where would you want to use this? Usually if some of the hairs are generated from a flat plane and they're curling in a direction that doesn't look natural and you want to have it lay down flat on the head, you would just use that to quickly twist that particular clump into more of a rotational direction that kind of works. Additionally, we have sub-clumping, so meaning this is a clump overall as a primary shape, and then we can add additional clumping within that will essentially break these up into smaller segments to kind of separate them and give them more randomness, so that one cluster or one clump is then additionally sub-clumped to kind of give it more, breakups and randoms. So yeah, you'll have to find a balance between what looks good as well. And subclumping together with subclump random, that's a value that, or an attribute that will decide whether it's going to clump closer to the next hair to it or to one further away from it. So that's a randomizer as well. The clump interpolation is quite nice. This attribute only works with when you have multiple clumps close to each other. So this attribute essentially looks at the overall volume or hairstyle and finds a place where they can blend together. So it doesn't always follow the perfect polygon shape, but it might decide, oh, there's another clump next to it. Can we blend together and find more of a unison kind of hairstyle? So that's also a nice little attribute over there. Interpolation range, that's the distance, how far it's going to essentially blend. So those two kind of work hand in hand. Clump interpolation, you can see they're all splayed out very far from each other, and as soon as I increase the clump interpolation, they're going to blend into one more overall flow, which is great. So I'm going to show you guys in the next little cheat or trick, if you want to call it that. I'm going to select the actual hairs and then convert those into curves, so that we can utilize those curves to generate new hairs from again. So instead of that being directly associated to the piece of geometry, we essentially generate new curves off of each of these hairs, and then from that you would then generate new hairs again. So to do that, you need to essentially select the polygon plane or the surface that you want to use as a guide, and then all the hairs associated to that particular surface would then be converted into actual hairs. Now, just a quick note on this: before you go and say export, you have to be careful, because if you say export 50 hairs per clump, it's going to essentially export whichever pieces of geometry and 50 hairs per clump and convert all of those into curves. So you want to just use that or a simplified version of those hairs instead of using all 50 of them. So just before you do the export, you need to go to your actual hairs per clump and reduce that to a reasonable value. Think of it this way: the more complexity you have, the more hairs you have, the more difficult it is to manage. So you have to first of all settle on the hairstyle, and then you have to settle on a number that kind of propagates or evens out the approximate hairstyle, and then take it from there to convert those into the curves. So usually around 10 is a good number for the actual hairs. And then we would go into the export option. You want to choose your path when you want to export that, so you can click on set. It's going to open up the actual save window. You can create a new folder wherever you want to save those, call those hair export, or rather curve export. And then choose the path. Let's call this something like curves. And then that's where it's going to save those curves for us. In the options, some of the checkbox options that you want to make sure of is you want to say export these as curves and not as geometry. Okay, so exporting those as curves will then try and look at the actual hairs and then generate the curves for you. So you can also structure it into a group so it's easily selectable instead of having them all dropped into your outliner. So that's a nice way of kind of grouping things. If you have multiple surfaces selected, it will essentially create a group per clump and then drop all the curves associated to that particular piece of geometry within each of its own dedicated groups. So that's essentially how that works. For now, it's just a simple single surface export, so I really don't need that option. And then the last option that you want to make sure of is keep the format to FBX. OBJ does not export curves, it only exports geometry. So you have to use FBX, which is Maya and all Autodesk's universal file exporter. So any animation, any cached information, lighting, camera movement, all that stuff essentially saves in an FBX file. OBJ does only point count or point or vertex placement, if you will. And then lastly, what you want to do is just make sure you select the surface that you want to export, and then click on the export from selected GMH surface. and that will run through the process of exporting the curves. It says they're p-plane 24 curves, which tells us it actually used the physical name of the surface as the name of the FBX file. So if we change this to flat plane, that's going to be flat plane as the file name kind of previews at the bottom. So now I'm going to open up a clean Maya 2016. I'm going to bring that into view, and we are going to import. I'm going to go to my desktop and go to the curve export, select the FBX. It's quite small, 46 KB, very small. And I'm going to hit frame to frame that in the viewport, and as you can see, it exports 10 curves for you. We have them selected. It says selected object 10 in the viewport. So that's everything went perfect, exported them successfully. The only difference that you'll notice is that the geometry of the curves are not nearly as detailed as the one we have in the previous. So think of it this way: it uses the overall shape interpolation when it does the export. It does not export as those wavy shapes. If you really want that, then you have to go through a much more complex process to set it up. I'll show you guys in a different video at some other points. For now, if you want to have the same level of detail, you associate your regular Maya hair to it, and then in the properties you would just up your subdivision segments or segment subdivs, and then you can change your waviness, your noise, your curl, and that will essentially give you the same kind of details as you had previously in the GMH script. So associating a regular Maya hair system to this, all you have to do is select all your curves. You're going to go to your FX tab. I'm going to go to your nHair, and then what you want to do is say assign hair system. There's no hair system available in the scene, so it's going to ask you to create a new one. So we're just going to click on that, and that will then generate dynamic hairs for us that will automatically be simulatable. You can see it's just dropping down as it would in any dynamic kind of simulation scenario. So once you have that, the last thing for us to actually see the hairs previewed in the viewport as well as in the render, just for a quick preview, you can see if I render this out, there's no hairs being previewed. So what's happening with the assigning the new hair system, it's essentially just preparing the actual original curves, creates duplicates of those, and assign a dynamic simulation property to it. It locks the base and the end is loose to kind of fold down, and then from there you can then assign either geometry to it. You can actually extrude along the dynamic hair if you want, or you can associate a paint effect stroke to it. So it's quite simple. You just select the whole thing, select everything, then you want to go to your nHair, and then there's an option under here to say assign paint effects brush to hair. By default it's going to use the most simplified paint effect stroke and associate that to the hair. But if you go into the paint effects library, then you can choose pretty much any of those presets. You can use straw, you can use plants, you can use tree branches, and then assign actual hairs to that, which means it's generating branches to follow the hair follicles, which is, you know, quite interesting. Not that we want to have that in this particular situation. So for the sake of simplicity, we're just going to say assign paint effects to brush. Paint effects brush to hair. Just click on that and it will automatically assign the actual paint effects to that. Once it's green like this, and if we deselect that, you can actually see the paint effects. Thus they will also render out as is. They don't look so good in the preview at the moment because we haven't played with the materials. We can assign a V-Ray hair system to that. We can change the thickness and also some of the more internal properties to reduce the chunkiness of the actual hair follicles or the hair fibers. So it's pretty much the same process as what we had in the GMH script. Once you have that selected, you can go to hair system, You've got your clumps, same properties. You've got the graphs. You've got under the dynamic properties, there's ways to reduce the hair to be less stiff or more stiff. For instance, if I simulate that and I increase my start curve attract, I can bring these back closer to the initial hair. So now when the wind blows, it won't break the hairstyle. It will still try to get itself to morph back to the original style or shape, which is great, especially when you have a very cartoony hairstyle and it's always this like an anime kind of hairstyle, and the wind should be there. There should be some sort of dynamic simulation, but you don't want to suddenly lose the whole hairstyle that you've been working on for a few days. Okay, so that's essentially some of the basic properties that you guys can go and play with. Right, so going from GMH to basic Maya hair is pretty much a very straightforward process. It's not too hectic. So the more time you spend in GMH to generate some really cool hairstyles and pieces of geometry, the better this result will be at the end. Okay, I personally prefer working with generating the curves afterwards and then using a regular Maya hair system instead of keeping all that history attached to the GMH script, purely because it simplifies the process so that when we get to actual character animations, that we don't have to rely on other internal script properties to hold things together. So by having the curves, you're breaking away from the actual GMH script and keeping things simple to Maya, and you don't have any weird things that might break eventually. Okay. Right, I think that's it for now. We can do the next one maybe on Monday when I'll talk about the fiber mesh, how to use ZBrush's fiber mesh to generate hairs. And I will also talk about XGen. XGen is Maya's built-in primitive geometry generator. Very cool, but very technical in many aspects. If you don't like scripting and expressions, it's probably not going to be your most favorite thing to do, but you have some powerful tools to your disposal.